Well, good morning, everybody. First of all, just to get us started today, I've got just a quick announcement about next week. On Monday, I'm going to be taking that day off of work, so won't have a video early that morning, but we'll pick back up again on Tuesday. Now, yesterday I was in Manhattan, Kansas, and I got a great question from a guy that was at the talk I was at. And the question was about snow and nitrogen. Now, to get us set up with that, I thought it'd just be good to look at season-to-date percent of normal snow. And this goes through yesterday morning. This map, it's on my website. It'll update later on today about 9 o'clock. We've looked at this several times, right? This is just looking at what this season gave us in terms for percent of normal. And lately I've been showing you this one as well, which is the departure from normal. So the other one was in percent, this one is in inches. And we've kind of covered this again and again and again. But just as of late, there was a little bit of snow that snuck through over the last 72 hours. We can see the snow coming through this region. Of course, we've built in some better snowpack here in the northern plains. And yesterday, some really heavy snow. Last couple of days, that came out into this part of Nebraska, Kansas, clipping Kansas, I guess, and hitting this part of Colorado. Now, overall, just when we think about the broader context of where our snow currently is, this is the current snow water content. And the question was, a lot of growers had talked to this particular guy about the value they find in the snowpack in terms of helping to put nitrogen back into the soil. And I didn't get a good chance to go read a lot of papers on this, so I don't actually have an answer for you yet. But I think it'd be a fun one to kind of tackle to see if there is some process by which snow is more efficient, maybe than rain or just part of the natural cycle, to get nitrogen back into the soil. Because certainly he had heard some anecdotal evidence of that. But one thing is really certain about this year, and that has been the lack of snow. In fact, it's been one of the least snowiest winters for most of the United States, even part of the Canadian prairie, going back quite some time. So this is it. This is where your current snow water equivalent is. And if we're thinking about the nitrogen cycle, I'd actually say, and this was my response, I kind of find a more important part of, maybe a more fun part of the atmospheric way by which we can fix nitrogen is through lightning. And I believe, now I have to go back and look at this again because I just remembered the question early this morning. But it'll be, I believe, about 5% of the total amount of nitrogen that gets into the soil is fixing due to lightning. And certainly as of late, despite the fact we haven't had a lot of good snow cover, we have had quite a bit of lightning. Over the last 24 hours, there's been nearly 200,000 strikes, cloud-to-ground strikes here across the United States. And even early this morning, we continue to monitor some pretty powerful thunderstorms, which yesterday hit parts of the south, bring in quite a bit of hail into this area. And still this morning, still a lot of lightning. So I don't know. It's a good question, and I'll have to keep digging to see if I can find more about the impacts of snow on nitrogen. Now, if we look back over the last 18 hours or so of rain, I love everything about this animation. It's a slow-moving low. It hit that central United States area, which has been really just missing out on a lot of rain. And I drove home in rain the entire way last night. So great just to be in rain for a while over part of these, these very, very dry states. And again, we had some pretty nasty storms to the south. You can see them firing up here. And this also brought in some moisture into Arizona and New Mexico coming out of Southern California, just in limited areas, but it did. Now, if we look back over the last 7 days, you get this. Now, remember, I make these maps just once a day. I make them every day with data valid to midnight. So our previous 7 days, snow, mountain snow. Remember, we're still only a week away from the bigger events that hit California. And then a lot of flooding in parts of the southeast. And remember that low that started here and just rolled up the east coast. So I just kind of put all this into the broader context of where we are as we are transitioning into spring with respect to water resources. And that's what I'm going to continue to do today. If we look at our newest drought monitor released yesterday, we've got this. A couple of fun things to do with this. If you come over to the data tab, let's go to time series. And what it'll do is it'll paint a time series here. I'm just going to use the whole country, but you can choose your location if you want, all the way down to the county level. And we're just going to look at area of the U.S. covered in some form of drought. And what I'm curious about is going back to, this past 6 to 8 months, how much drought area has been reduced. Now, I go ahead and include the D0 area, and I do that just because it shows where we're abnormally dry. So if we slide to the very end of this, you can see as of the latest drought monitor, we've got 48% of the country in some form of drought, D0 all the way to D4. But if you just want to include the true drought categories, D1 through D4, it's about 21%. And what's important is coming off of last fall, that means we've come down from about 60% to the now 47%. And on the D1 to D4, we came from 40% down to about 20. So this was a good winter to see some drought reduction. In fact, we can go find where it is by clicking on the maps and going to the change maps or the comparison slider. I like the change maps. And let's just take it back all of winter, 3 months. And there you go. So basically since December 12th through March 5th, we've talked about this a lot. The greatest relief in drought has been here, where we've seen up to a couple locations of 5-class improvement in drought. Now, just taking this and broadening it out, keep mentioning, I should mention more about Canada in my videos, but I do want to show you the North American Drought Monitor. Now, I'm not sure why, I've never looked into it, but the North American Drought Monitor only comes out once a month, and it's in the middle of the month. So this is the one that was released, when you're going back here. Can't find the date on this. Well, I mean, here's the date it's valid for, but I forget when it's released. I think it's released in the middle of the month. And so we'll get a new one of these in a week and a half or so. But I mentioned yesterday how much of the Canadian prairie was still in some form of drought. And it's the whole, it's actually almost all of Canada is still in some form of drought. Most of that coming from last year's massive omega block in spring and summer. So there's big questions in Canada about this upcoming year and the water that can be returned, because I can find an area right in through here that from April to October saw less than 120 millimeters of rain. So I mean, that less than 5 inches of rain on an entire growing season, and that became very problematic, of course, for growers there. Another way by which we can assess water resources is to use NASA's GRACE mission. Now, this is a satellite-derived drought indicator, and that G in GRACE is actually a part of how it uses gravity, measurements, microfluctuations in gravity, to make some assessments about water moving beneath the surface. And when you come to this site and you just Google NASA GRACE, you'll find it. You have the option of looking at ground water percentile, root zone soil moisture percentile, and surface soil percentile. Now that's important to talk about, because it's not percent, it is percentile, which means it's compared to a historical average, in this case 1948 to 2012. So when you see these values, it is compared to that time frame. So just want to make sure you know it's not absolute. Now, what is interesting about soil moisture is that it is one of the variables that we do the worst job with modeling, and in fact, because we have such few measurements, we don't have a lot to verify the model. Now, that is not to say anything or to throw any shade on these guys like NASA doing this. What they are capable of doing is absolutely incredible, but they would be the first to admit as well that without ubiquitous measurements of soil moisture, it is extremely hard to capture the way the hydrologic cycle works in the soil, because it's such a hyperlocal effect. I say all of that because I'm going to take you from this soil moisture drought indicator, which is surface-based, and I'm going to take you over to the root zone map, which is here. And it looks kind of similar, but it looks much different than the root zone soil moisture maps I show you from the Sport List program, which is also a NASA program. Now, when I show you these maps, what I want you to see is the change in the maps. I am not so interested in the value. It's more about ballparking where we have drought issues and where we're seeing changes. And I bring this up and spend some time on it because talking with several growers recently, in fact, I was in Indiana earlier this week, one grower said, hey, we've got tile draining in parts of Illinois where he's from. And he says, shouldn't that indicate moisture is down there? Now, again, I'm not an expert in tile. I understand the principle of it, why we have it, and what it's capable of doing. But he says, your maps look like things should not be able to be draining, yet they are. And I said, yeah, I understand that. And I don't have an answer for you. But I do know that we're going to continue to monitor areas like the one I've highlighted here, because there are regional drought issues in here that are quite severe and quite bad. Now, I thought it'd be kind of interesting to show you this same map a year ago. This is what it looked like. So I archived these because I find them so incredibly important. This is 1 year ago on March the 8th. Again, sorry the maps kind of bounce back and forth here a little bit with the colors, but that was a year ago. This is now. Forgive me. This is a year ago. This is now. Now, what's interesting about a year ago is how dry the upper Midwest, the Western Corn Belt, the Northern Plains were. We still had a streak in through here and down here across the South. But I want to talk about this area because a year ago we had 6 to 9 inches of liquid and snow that was sitting on top of dry soil. And what happened is that from March 8th to May 8th, that snow melted. And this is where we saw major recovery. So you see how I use it in a relative term? And this is what helped buy this whole region of the Dakotas, Minnesota, Wisconsin, this whole spot, buy time during last year's drought episode that happened in spring. The vulnerable areas were here. Okay? So again, just a neat way to assess this, and also want to point out how much water was in the Western Mountains last year with respect to all the snowpack we had. Okay, so let's look at another variable. I'm going to look at temperatures next. This is just a quick look at the time period of, February 1st through March 7th at temperature ranks. And to be honest, a lot of growers in the West really need to start to see some heat accumulating. We are very far behind normal on the accumulation of heat. And if you look at just a standard GDD calculation or growing degree day using a base of 50 and a max of 86, we have places in the West that are off by a couple of weeks of accumulating some spring heat, whereas we've got places here in the central U.S., the mid-south, that are up to 150 GDDs above average, and that's going to continue as the warmer air sticks around in this area. Now, I was thinking about this, and I want to take you over to my website, agweather.com. I know a lot of you visited it, and I just want to go to a spot and have a look at a couple of things you can do here. So if we go over to select your location, I'm going to pick Des Moines, Iowa. I've picked on Des Moines a lot. You start typing it in, but you need to click on the drop-down menu so that it puts the index value, and that's how I built this. Sorry, I built it. It's not built by some professional front-end designer. It's just me. So you click submit, it generates the forecast right now, hits my databases, and then it'll go right here. You click here, and you get this. Get a lot of stats. You get radar right now. Look at the snow on the back side of this, by the way. And you get a forecast for your kind of different models here for the next 7 days. I want you to come down here. And what's interesting about Iowa, let's take a look at a couple of different things. I started this off with a discussion on temperature, so let's click on the year-to-date temperature. And as you look at it, this is how mild things have been, throughout the end of January, most of it. We had 2 cold episodes. That was it. And I bring this up because I want you to also click on the radio button. This is year-to-date GDDs. So right now, Iowa's already picked up 122 GDDs. Why I'm showing you this is that I also put blue bars showing the last 40 years of when there were frosts. So like, for example, on this particular date, April 8th, there were 3 times that April 8th was the last frost. Just understand that the typical last frost date is somewhere here in mid to late April. So if we kind of look at this as a distribution, it's somewhere in this area. But we are right now outside of the 20-year range on the accumulation of early season heat. And I'm just bringing this up as a reminder that the colder forecast we do have coming in, starting in the second half of March and possibly through the first week of April, means we're going to feel like we can really get going, and then they're going to throw the brakes on this in a big way here coming up pretty soon. Another thing to do in this is to look at the year-to-date precipitation. And I really like this graphic because here we are, and plus I got the statistics up here, 93.7% of normal. But this, you can click off years if you want, and they'll just kind of disappear. And I want to show you 2023 where they finished. So a normal year is way up here, somewhere around 36, 37 inches. Last year they finished with about 23 on the whole year, and we're already starting off. So this is one of our more vulnerable areas that are in drought. And I just want you all to take advantage of the tool. It's there. Please play around with it. I've only got 30,000 cities in my test database, but I have been planning for the last couple of years to make a pretty massive expansion on this. So I'm pretty excited to be able to get that done, hopefully later this spring. All of that was just to tell you where I think things are, and now we're going to ask where they're going. Now, this is interesting. Since the beginning of February, we have had that ridge, and that helped accelerate the jet stream through here. It has dove into a broader trough over the west. That's repeated storm systems hitting the west, big ridge building east. This is also part of the setup of the split in the flow that I kept talking about between Hawaii and Alaska. Now, we know that we've been waiting and watching to see if anything in this pattern is about to change. So again, speed through here, deep troughs in the west, big ridges across the eastern half of North America. That's what's driven the pattern that we've seen as of late. All right, top-down view. Let's see how this is going to change over the next couple of weeks. So we have a deeper trough that cuts itself off this weekend over New England. We're going to take a new look at the snow and the potential for some heavy rains here. The west, the northwest, we still have it. Okay, the flow's still there. See the ridge? The speed coming in the flow? We still have the northwest getting hit another 2 times between now and midweek next week. Okay, so that's between now and midweek next week. Now watch. Shortly thereafter, next Wednesday and Thursday, here is the catalyst for change. It's that trough. And what this trough is doing is it's digging in to where for most of the last almost 40 days, we've had a ridge in this area. But the pattern is starting to evolve, and we're going to start to push a ridge up toward Alaska. There's already higher heights around Greenland. And the net effect of that is this system here that gets pulled through the 4 corner states is going to slow down next Wednesday, Thursday, and Friday and get stuck on the backside, which is the downwind side of this ridge. And what will be important about this is that we don't yet know exactly where that low is going to emerge. But what I will be watching most carefully is what it means for precipitation coming into the plains, which has been missed in some of these recent forecasts. What we do see after this, though, is that kind of pushing that warmer air farther to the north is displacing colder air east. And we talked about earlier this week, this is kind of co-located with the polar stratospheric vortex, the one that's sitting here. And the net effect of this is to start to drop some much colder air east. Now, the way a pattern like this works, very dry west, northwest flow coming across Canadian Prairie, which means this area will be dry. And it's only going to be along the southern part of this and then possibly up the east coast that we can get a wetter look out of this pattern, which is the way I think we're going to spend, let's call it about a week from now and beyond. The rest of March, I think, is how we're going to spend it looking at a pattern like this. So what does all of that do? Well, let's kind of break it down by just starting off today. Early this morning, we still had the winter weather advisories here and along the Front Range. We also had a broad area under flood watch down here because of some of the recent very heavy rains. Those are kind of the 2 main target areas currently. Today, remember, we do have the risk of strong to severe storms from eastern Texas all the way over to parts of Alabama. And then tomorrow, this is going to curl up into the southeast, right in through here. So if we watch this on the high-res NAM model, let's just play this forward through the middle of the day today on Friday, playing through Friday evening, and then getting us out there to early Saturday morning, watching the low roll up the east coast. Here it is Saturday night, snow on the backside, and then we get all the way to midday Sunday with that pattern. Again, real quick, this is this morning. Again, we're watching for those severe storms south today, southeast tomorrow, snow on the backside of this, colder air, heavier rains pulling through the Ohio Valley, into the mid-Atlantic, into New England. And then again, on the backside, chances for some snow squalls, even some lake enhancement here. While that happens, next trough goes into the northwest. To see it from there, I got to switch over to the models that run out longer, 10-day models. This is the GFS and the European. So here is the system we've already watched. Rolls through New England. Now take a look. This is going to be on Saturday night and Sunday morning. When do we get the conversion over to snow and how much? If we pull in off that warm water, warmer surface air, that's going to keep pushing this rain-snow line farther and farther into the interior. Very tricky forecast for the Northeast. But by Sunday night, we can see the snow curling around the backside, some enhancement by the lakes here. And after that system leaves, rebound in temperatures in the Midwest, and the next system comes in to the Northwest. Now that next couple of systems that hit the Northwest, again, this is early next week, Sunday into Monday and Tuesday. This is where we start to see the pattern trying to curl itself up into that omega block, right? Well, not omega block, that omega pattern. So something like that. And we're going to watch this trough possibly sink south in retrograde versus running across the United States. So you can see spreading out on its warm front, precipitation chances here a week from now. But overall, that trough went here. And so there might be some rain out ahead of this, helped by this high pressure cell here, pumping some moisture into it. But about a week from now, that's not going to be a big deep low, I think, that rolls across the country. I think the upper level low sits and spins here. Now, the GFS lets it get out into New Mexico, Texas, Oklahoma, and parts of Kansas, and possibly roll on out. But we're pretty far out in an operational run to kind of give any sort of confidence in this. So what do we know? Well, the European model, the AI version, still leaves a hole here. And I'm going to question whether or not, if that low really sits here, late next week and retrogrades kind of in this direction if we could start to fill some of this in. But overall, we continue to see wetter than average conditions and pushing through here in the Midwest, very much in the south and up the East Coast. And again, our dry swath right in through here. So that is the European model solution. Let's add up the actual, that was the European AI solution. This is the European operational run. And if I just keep going, let's just go out 10 days. It's got a very similar look, right, to its companion AI model. A little bit different projections. I'm sorry, I will be fixing that soon once I come off the road. But again, I'm seeing this drier swath. What's the GFS say? Well, the GFS, because of the way it handles that second low, so ready, this is next Thursday. Watch us go from next Thursday into Friday, Saturday, and Sunday. Do you see it fill it in? It's all going to be about the way that block, that omega pattern, forgive me. Just in my head, you put the word block after you say omega, okay? But that omega pattern could drop below and through here and pull that moisture in. Do not know. I'm just telling you the chances are there, and we have to just watch the model differences. On the snow side of it, let's just go ahead and add up the European real quick. And what I'm really watching in this is the snow that's on the backside of the current system, which is some of this in here, and then how far into the interior of New England do we have to go to get the snow. That's going to be a tricky forecast. Take a look at the Cascades in the Sierra Nevada with the next two waves coming in. The GFS adds a similar picture. Let's just take it out a week like we did with the European model. We're going to pause it right there. So again, very challenging forecast into the interior of New England. All right, back to my probability maps as we work our way toward the end of this. This is looking at the next 10 days, the chance of staying under 1/10 of an inch. And this will be the spot that I'm going to have to watch most carefully. So this would be the European model solution on that. And before I show you the GFS, I want to show you the wetter side of it. So this is the 10-day forecast of who's got a chance of getting an inch. So thankfully, we just brought all that moisture into this area, but we still have two more systems that could possibly help in this region. But this is where our wettest location is going to be. Let's go up and switch this over to the GFS ensemble. That's the probability of an inch over the next 10 days. But take a look at the risk of being drier. Notice that it is smaller in this area than it was in the European in terms of probabilities. So we just need to weigh that the GFS is wetter in this critical area that needs a lot more moisture. Okay, from there, just remember that once we get out to day 10, the atmosphere is splitting its jet stream here. That's the flow coming over the top. Subtropical is there. So it should be no surprise that the precipitation pattern is drier west. The northwest flow is drier into the interior, which we were expecting the models to trend toward. We stay wetter here. European was the first to pick up on this pattern. The GFS and the CPC followed slowly thereafter. Okay, with all of that, that change in the upper level pattern will also drive in some cooler air. And right now, the newest CPC update says there's the risk of colder conditions March 17th through the 21st down here. Now that's that same spot we've been talking about for a while. So let's go and have a look at how the pattern needs to evolve to get there. There's your next 7 days for frost potential, and this is what we're going to watch the highs do. Now, we still are tucked away in the pattern we've been in for a while over the next 7 days. So again, a lot cooler here because of the current system, but watch the temperatures rebound by this weekend. So this is Saturday, here we go. Sunday, Monday, already jumping back up. Now, as we go into next week, Tuesday into Wednesday, this is about the end of this kind of setup on the pattern because it is after this that the big omega pattern begins to set up and it's going to start to drive cooler air in. So day 5 through 10, this is where we're going to start to limit this cooler air. And by day 10 through 15, there's the change. Now, how much cold air gets into this region starting around the 17th, that is still yet to be determined, but I'm going to be watching this with you. This is the ensemble forecast looking at the probability of getting below 40. So out this far, if you're going to talk about a frost risk, let's at least try to see where the maps are saying the chances are of getting below 40. So just look at the color gradient. This is on the morning of Sunday the 17th. Let's play this out there to the morning of the 18th. Let's go out there to the morning of the 19th and the morning of the 20th. There it is. That's going to be the time frame for which I think we sink into this colder air. Now from there, we know that the longer range models continue to keep that colder air in place to finish the month of March, which this is what the week leading up to Easter looks like. And then after this, we might have a cooler start to the month of April, but then I think it's going to fade. I think we're going to get into not only a more mild April as we go forward, but also one that is going to be favoring, I think planting windows that are going to open up, especially in the Midwest. This is a cold feedback. It's very well known in the models that this time of year with all the snow here, the models tend to keep that colder feedback in the west. But on the precipitation side of it, let's look at a 30-day map ending on April 15th. So what the models are suggesting is we continue to keep this region wetter. We're a little bit drier in through here, wetter in through this area. And to be honest, that lines up nearly perfectly with our March analogs we've been discussing for a while, doesn't it? Okay. From there, the big unknown is the MJO progression. We've talked about it all week. The newest updates continue to take the ensemble average and crash it back into null rather than flinging it way out here. The duration of the cold air that's coming up is dependent on the tropical connection, which means if the MJO does in fact sweep out into phase 8 and 1 and spend some time out there, then the risk of colder conditions in April extends. That's kind of the big idea. So where we need to finish this video is a recap. This is the way things have shaped up with our El Nino transitioning toward neutral conditions here in late winter, early spring. What we were watching for the last couple of weeks is for the cold water to finally surface right there. You're going to see it just in a few seconds. Here it is coming out at the very beginning of March, right there. And so what's happened is in that region called Niño Region 3, we've watched the temperatures drop off about a half a degree lately. But that Niño Region 3 is a broad area in here, so it's still averaging in some of the warmer water. Now I'm just going to tell you what's going to happen. There's going to be a strip of colder water. It's probably going to have waves in it that shows up over the next 40 days right in through here. And it's going to get a lot of attention. What we have to do is we have to remember what this means in the broader context of our forecast. So one new piece of information has been added since yesterday. And what I've got for you is what I talked about on Wednesday. This is your forecast from the CFSV2 model versus the European. And the main thing we talked about earlier this week is that one crashes El Nino very, very quickly, which has a reflection of cooler water in the North Pacific, whereas the European model does much slower and keeps the North Pacific warm. Both models keep the Atlantic warm, which means we have a hurricane season risk. So I'm going to take you to the seasonal forecast from the CFSV2. We're going to look at North American 2-meter precipitation, total precipitation data, and this is what it's got. Now, we talked about this earlier this week. You can go and look at this yourself, the March, April, May transition into May, June, July. And what the model is attempting to do is creep drought through the plains and spread it into the Midwest. You can see that here, which goes up into June, July, August, then July, August, September, and August, September, October. Now, what the model is attempting to do, because we brought this up earlier for the Canadian Prairie, is basically give us a pattern that might do something like that. And there's our large ridge that forms and the storms that could result in the Canadian Prairie because of it. Excuse me. And maybe the wetter risks east and the wetter risks or cooler risks. Let's rephrase that. The lower risk of exceptional heat west. It is important to note that this would also end our Panama Canal issues if we're that wet down here, really starting in summer. Okay, we compare that to the European model, which the European model on its seasonal forecast looks entirely different. It comes in with a really active severe weather season in spring with an enhanced dry line. It then keeps this pattern around with the driest conditions in the Four Corner states and the High Plains, wetter here, but then never lets this out into the midsection of the country. That's June, July, August, and July, August, September. In other words, we build heat into the Great Basin, into the Rockies, and into the Western Plains, but it's not getting all the way over here to like the Ohio River Valley. This model also is calling for a very active hurricane season, as you can see here. So what are my last slides? Well, they come down to the newest forecast from the NMME, the National Multi-Model Ensemble. Now, the maps I'm going to show you are the composite of 8 different simulations. See them down here? And this is what things look like according to that model for April, May, and June. I like it. We need moisture in this area. I don't want dry here, but we need the moisture. This is what it's done now for May, June, July. Again, these are the models in question, and this is what it's got. Kind of similar. This is what it's got for June, July, August, and this is where it deviates from the European. by building in all of this dry conditions into this area. The models all agree on this, but they do not agree on this. All right, and let's just keep going. What about July, August, September? Very active potential for hurricane season, drought spreading into this area. And we're just taking these models at face value right now, because I honestly tell you, we did this on Wednesday. The analogs don't fully support the drought building all the way into the Midwest. I am, and I'm just going to state this again, I am most worried about this section of the country and ridging later this year. That's what I'm worried about now. And if that changes, I will tell you. But that's the spot that I'm most worried about given the historical analogs. There is a risk of this also setting up here over parts of the kind of the Appalachian Mountains and southeast. That's what I currently think the pattern could do, which is different from these forecast models. I'll be very much looking forward to NOAA's interpretation of this mid-month. So from there, I do want to show you a national view, and I just want to go back to April, May, June, international view, and I want you to see this. Because these models continue to paint the risk of drier conditions coming into Brazil here while keeping this side of Brazil wetter. We've been having this discussion about what this could mean going forward, because that's been an area over the last month we've seen dry conditions continue to build in. Now remember, when you think about Mato Grosso, where the big growing areas are, we kind of think more on the eastern side of that state. That is not to say there aren't areas in through here that are dealing with drought. But our question is, how long does it last? And I have one last thing I want to share with you today, which is the transition I was waiting to see in the models. Let's do it. There is your next 10 days. Now what's changed? We've gotten drier in the forecast here. It's stayed wetter in Argentina, Uruguay, parts of Rio Grande do Sul, but it's gotten drier in the forecast over the next 10 days. And the newest run from the European model, which I showed you all week trying to fill this in with better moisture, the newest run of the model, so this is just model data. This is a 30-day outlook, so this goes through April 6th. And now as we slide into the middle of April, it's kind of kept the drier signal around. And that is all going to be related to the way that MJO transitions. We expect southern Brazil and Argentina to stay wet, same thing with this corner. But the question is, can we see if the models are really catching the signal and bringing in dry air? That's yet to be determined. So that is something you got to watch. All right, a lot on Friday here, but just wanted to kind of give you my full thoughts. So we will pick this back up on Tuesday. Have a good weekend, and I'll talk to you then. Thanks.